So hello everyone, welcome to OneClass YouTube channel. My name is Devansh and I'm a senior tutor at OneClass. So in this session, we'll be solving a few pre-calculus problems, and I think that these problems are going to be at high school and they can be at university level. Means you can obviously get aptitude questions from this session also. And so a little bit background about myself. So I'm in the final year of my graduation in aerospace engineering. And if you need any homework help or if you want any tutoring or one-to-one live sessions, then you can check the links in the description below. And so without wasting your time, I'll just start with the lesson today. I hope it is visibly up. So we have first question. Just a minute. This is question number one. So it is asking that what are non-linear functions? Okay. Please don't judge my handwriting because I don't have a lot of good practice with these whiteboards. Yeah. So I'll just go with the definition given here also. So non-linear function are the functions that are not linear functions. Okay. That is understood from its name only. And therefore they have the opposite properties of a linear function. So I'll just tell you with an example. So for a linear function, like basically x is directly dependent on y or y is directly related to x, or let's uh, I'll just tell you one equation. Let's say y equal to 4x. So basically you can see that the y is directly related to x, or direct in like directly proportional to x, and we have the constant of proportionality, that is 4. um, all equations of straight line like y equal to 4x or y equal to x plus 3, x plus 3 4 34, or let's say y equal to um, 2x minus 4, or let's say x equal to y plus 18. So these all are linear functions because the value of x is directly related to value of y. But for non-linear functions, let's say this the given function also, y equal to x square. So you can see that y is like y is not equal to just x. It is equal to the power. It is equal to x square. So basically it is y is not directly dependent on x or directly related to x. It is like it is directly related to x square. Now if I so this kind of equations are nonlinear equations like this one, or y equal to x square plus 38x plus 2, or let's say equation of circle, x square plus y square equal to 1, or let's say, so basically for nonlinear equation the power of exponents are not like equal. So example, a nonlinear function is y equal to x square because its highest power exponent is 2, not 1. And we can like equation of parabola of y equal to 4 x square, or x equal to 4 y square. So these kind of equations are basically nonlinear equations because the dependent variable or the independent variable, like one of them are the power should be equal to 1, but here in this case the power is 2. Or we can also write the cubic function, so x cube equal to y, or y cube equal to x. So these kind of functions are nonlinear, and these kind of functions are linear. So I think that is sufficient for understanding. Like with examples, we can clearly understand that. Just remember one thing, that if one value is directly related to another, like I can also convert this y equal to x square in a linear equation by saying let's say x square equal to k, then y equal to k. So y equal to k will be a linear function, but x square equal to k will be a non-linear. And obviously y equal to x square is also a non-linear. So we can convert, like in mathematics we do, or in engineering problems we do such kind of practices because solving linear equation is much more easier than solving a non-linear equation. So we always try to convert non-linear equation into linear equations, and then we try to solve them. So that is pretty much everything for this one. So correct solution. Good work. So I have question number 2. How do you verify cosine? I'll just first write, I'll go with red color. So how do you verify cos square x minus sine square x equal to 1 minus 2 sine square x? So cosine square x minus sine square x equal to 1 minus sine square, oh, 1 minus 2 sine square x. So for proving such kind of statements, what we do, we'll go with one property of trigonometry. So that is cosine square of x plus sine square of x equal to 1. And I can solve this for cosine square x. So I'll get 1 minus sine square x. Basically, I have just subtracted sine square x from both these sides. Now I will substitute the value of cosine square x in this one. So it will be 1 minus yep. So where we were, yeah. So 1 minus sine square x minus sine square x. Now I can just write this as 1 minus 2. Voila. So we have finally proved this, and in this way we can like convert. We can also substitute this sine square x in terms of cosine square x, and we'll get 2 cosine square x minus 1, but that was not given, so no need to go for that. And here also they have followed the same procedure, because this is the procedure for verifying the identity. And I can just say correct solution. Nice job this time, nice job. Okay, so we'll go for question number 3. So what is sigma? I think they haven't mentioned like sigma in mathematics because sigma can have different meanings in physics, chemistry, engineering, material or material science, or let's say in aerospace also, like we have few variables known as sigma. So in the definition, I think they are telling about the sigma letter, and okay, so it is the sigma for summation. So here, um, sigma is the, I'll just read the line which was given by Junior Tutor. So it is sigma is the 18th letter of Greek alphabet. Sigma also means sum and deviation in the mathematics world. So let's say we have an equation, uh, not equation, let's say we have an expression, let's say arithmetic expression. So a, then sorry, not comma. Let's say we have a1 plus a2 plus a3 continental an, and um, then what we do, we'll write a2 in terms of a1. So a2 is a1 plus common difference plus a a1 plus 2d continental a1 plus n minus 1 into d. Then I can club all these terms. So this will become a1 plus, I'll take a1 common. Mm, I'll not write summation here. A1 common, and this will become 1 plus d plus 1 plus uh, 2d continental 1 plus n minus 1 into d. And I can write this as a1 2 plus this will be a1 will be n times, I think. Yeah, so a1 will be n times, or 1 will be n times. So this will become n, and plus this will become um, d plus 2d, d plus just a minute. This a1 will operate on this one only, not d. I'll rewrite this statement again. So I can write, if I take a1 common, then I can write 1 plus 1 from here till n, and this plus, and this will be d common, and it will be 1 plus 2 continental n minus 1. So I can write this as a into um, a into summation of 1 plus 1 plus 1. This will be n times 1. So a will be just n only. So a into n plus d times, this will be 1 2 3 till n minus 1 of n equal to 1. Let's say m equal to 1 till n, and this will be n minus 1. So basically summation, this sigma, sine or summation, sine represent the sum of a series or a series of numbers, and the in the bottom or here we write the lower limit, and on the upper side we write the upper limit of the numbers. So basically this m will operate from 1, so 1 minus 1 0, plus then this will be 2 plus 3 plus 4, continue till n minus um, m will be, sorry, this should be m, so this will be n minus 1. So if we have, let's say, n equal to 10, so this will be 10 minus 1 9, so 9 times. So that is, I think, pretty much all for this question also. Like, this is a very basic question, so I'll just write correct solution. Good work. Okay, so we have one more question. That is question number 4. Mhm. So we have question number 4 here. So we need to find the exact value of cos 3 pi by 4. Okay, so for calculating this, um, okay, so we'll be using reduction formula because they have used the reduction formula here also. So we'll use the reduction formula. First, I'll just convert this 3 pi by 4 into degrees. So this will be 3 pi by 4 into 180 over pi. So this will be, I'll just use my calculator, 3/4 of 180 divided by 4 into 180, 135. So this is nothing but cos of 135 degree, and 135 will lie in the 90. This will be 135, which will make 45 degree from this one, and this will be 135 degrees from positive x-axis. Now I can write 135 as cos of 180 minus 45, and this will become negative of cos of 45. So basically, if you don't like, if you don't know whether we can write whether we'll be getting a negative value of or not, what you can do, you can just take the write the value of cos 45, and you can see whether in which quadrant the angle is lying. So the angle is lying in the second quadrant, and in second quadrant only sine is positive, sine or cosecant. So cosine will be negative, so, so just add a negative sign here. So I'll, but we have already used the reduction formula and we have got the sign as negative. So I'll just write this as negative, and cosine 45 is 1 over square root of 2. I can just rationalize this, and this is the answer. So let's just check what the junior tutor has given here. Since the given angle is in second quadrant, we expect that our cosine function is negative. Yep, true. Note that cosine function is only positive in quadrant 1 and 4th. So we have cosine pi by 4 or 45 is square root of 2 over 2, and hence the answer is negative of square root of 2 over 2 equal to cosine of 3 pi by 4. So that is, I think, this much is sufficient for the answer, and I'll just write the solution given here is correct. So correct solution. Nice work. Yeah, so we have question number 5. So it is asking that what is the period of y equal to tangent of x. So period of y equal to tangent of x. So I'll just look at the solution given here also. So the solution, the period of y equal to tangent of x is the distance between two consecutive vertical asymptotes. So we can see here, I'll just try to draw this graph. Nope. Mm, yep. And let's say this is my asymptote, and let's say this is the another one, and this is 0, this is pi over 2, this is negative pi over 2, and the graph goes something like this, and it will go something like this. So basically the period for tangent x is the distance between two consecutive asymptotes. So it is distance between two consecutive um, so one asymptote is this one, and the another one is this. So I'll just find the difference between these two. This is pi over 2 minus negative of pi over 2. This is the period, and this will be pi 2 times of pi, so this will become pi. So the time period of y equal to tangent of x is basically the distance between two asymptotes, and that is nothing but pi only. So let's just check the solution given here. So period of tangent function y equal to, what is this, a tangent bx. Okay, this is the general equation, is given by pi equal to p equal to pi by b. Since in the given geometry y equal to tangent of x, it is clear that r b equal to 1. Substitute p equal to, so for general equation, like if you have any general equation like y equal to a tangent of bx, then that for that case you can find the time period. So I'll write this formula also, because not always you are going to get y equal to tangent of x for general equation, which is y equal to a tangent of bx. And Yeah, that is, I think that is all. So that is pretty much all for this question also. I will just move with the other one. So correct solution, good work. So we have, this will be question number 6. Question number 6. So we need to find the exact value of sine pi over 6. So I'll just first convert this pi over 6 to degrees. 180 over pi, this will be 30 degree. Now for that, first thing is that in the solution given here, we can first use the table, the general table, which contains the trigonometric ratios for 0, 30, 45, 60, and 90. So with this, I can clearly say that the sine of pi by 6, which is 30, is 1 over root 2. Sine of pi by 6 is, sorry, 1 over 2. Now there can be situations where you won't be able to find such kind of table, or basically such kind of tables you have to memorize. I have also memorized, like when I was in my high school, I memorized all these values because like every day we used to find the value of sine 30 and 40, and it is like when you go to higher classes and when you are in university, it is assumed that you must be knowing these values because these are the basic angles. And yeah, obviously we always have a calculator to calculate sine for the ratio of sine or cosine or trigonometric ratios for any angle. But yeah, it is a good practice that if you just remember these basic values, or these are only few values, and like you can remember this. And another approach is to use the unit circle. So I'll just use the coordinates of unit circle. So for coordinates of unit circle for 30, we have this coordinate as x is root 3 by 2 and y is 1 over 2. And if you have a unit circle, then sine of any angle, let's say theta, is the y coordinate. Cosine of theta is the x coordinate of that angle, and tangent is y by x. So for 30 degree, my coordinates are x comma y, and for sine 30, my y coordinate is 1 over 2. So sine 30 is 1 over 2. But again, if you do not have a unit circle with you and you are in a really hurry, or you don't have anything, like you don't have even a calculator, don't even remember the value also, and plus you don't even have a unit circle so that you can, or coordinates of unit circle, so that you can quickly just find the value of the trigonometric ratio. So I have one more method which I would like to share with you, that is using an equilateral triangle. So let's say, um, assume that this is an equilateral triangle, and let's say this is a perpendicular drawn. um, I'll just rub this and draw another one. Yeah, this is looking better. So this is I'll just remove the extra part. So we'll be taking the half. So for an equilateral triangle, all the interior angles are 60 degree. This will also be 60 degree. Complete this angle, and all the lengths or all the sides are equal. So let's say the side length is a small a, and if I draw a perpendicular from one edge to the other, to the base of the other side or the opposite base, then that perpendicular will bisect the base, this line, in two halves. So this will become a by 2 and this will become a by 2. So BD equal to DC equal to a over 2, and it will also bisect this angle. So angle DAB will be equal to angle DAC is 30 degree. So this angle will be 30 degree, and obviously this is a perpendicular, so this will be 90 degree. Now what we can do, we have a right angle triangle, we know the side, and for okay, so for cosine we'll be needing the length of this perpendicular, but for sine ratio we won't be needing any, we won't be needing this length, this perpendicular length. But yeah, we can obviously find this length with Pythagoras theorem. So I can write this as a d square plus dc square equal to ac square. Ad square will be small a square minus a square over 4. So this implies AD will be, this will be 4 minus 1 3, 3a square over 4 square root, and that will be a root 3 by 2. So we can clearly say that this is 30 degree. I'll just calculate sine of 30 degree. So this will be opposite side, which is a over 2. I'll just write the first the name. So that is DC over AC, which is a over 2 over a and a can get cancelled, and this will become 1 over 2. Yeah, so that is pretty much all. Like, these are three methods. The best one is to remember the values of such kind of trigonometric ratios. Second is you can use this triangle, equilateral triangle, or the third one is you can remember the coordinates of a unit circle, or if you have any unit circle. And yeah, there is fourth one, which is calculator. So these are the four methods, and that's all for this one. Yeah, so now we'll have question number 7. So in this question, it is asking that how to use double angle identities to solve equation. So double angle identities. So I'll just write the double angle identity first. So this is sine of 2 theta, which is 2 times sine of theta cosine of theta. For cosine 2 theta, we have three formulas: cosine square theta minus sine square theta, 1 minus 2 sine square theta, or 2 cos square theta minus 1. And then for tangent of 2 theta, we have 2 tangent of theta over 1 minus tangent square of theta. Now to use these identities, let's just take the example of, I'll take two examples. First will be for 30 and 60, and the other one will be for 45 and 90, because I remember the values or trigonometric ratios for these angles. So I'll just write first sine 30 is half, and then instead of writing this, I'll just write a table. I'll just make a table here. Then so here we'll have sine, cosine, tangent, and here we'll have angle, and rest I'll delete everything. So I know the value for we'll be needing for 30, 60, 45, 30, 60, 45, and 90. So for 30, sine is 1 over 2 root 3 by 2, 1 over root 3, and this is root 3 by 2, 1 over 2, and this is square root of 3, this is 1 over square root of 2, and this one is 1, this is 1, 0, and I think tangent 90 is, yeah, undefined. So we'll first start with 30 and 60. So for calculating, so suppose if I know the value of sine 30 and I want to calculate the 2 theta, which is 60 degree, so I'll use first sine of 2 into 30, which is 2 times sine of 30 is 1. I'll just write this. This will be sine of 30 times cosine of 30, which is 2 times 1 over 2, 3 over 2, and this 2 and 2 can get cancelled, and this will become square root of 3 over 2, which is sine of 60. And yeah, sine of 60 is square root of 3 over 2. Now for cosine, 2 into 30, we'll write cosine square 30 degree minus sine square 30 degree. So this will become cosine, cosine, cosine. Where is cosine? Square root of 3 over 2 whole square minus, and sine is 1 over 2, uh, yeah, 1 over 2 whole square. This will be 3 over 4 minus 1 over 4, 2 over 4, 1 over 2. And yeah, cosine 60 is 1 over 2. So in the same way, we can use the other two formulas also. I'll not use them right now because that is again going to give me root 3 over, or sorry, 1 over 2 only. And this we'll go for tangent now. Tangent of 2 times 30 degree is 2 times tangent of 30 degree over 1 minus tangent square 30 degree. So this is 2 times 1 over square root of 3 over 1 minus 1 over square root of 3 whole square. So this will become 2 over square root of 3 over, this will become 1 over 3. I'll take the LCM. So this will become 3 minus 1 over 3. So this will become 2, and 2 can get cancelled here. So this will be 3 over root 3 or root 3. Now we'll take the example for 45 and 90. So again, um, sine of 45 into 2 is 2 times sine 45 cosine 45, 2 times 1 over square root of 2 over 1 over square root of 2, and this square root of 2 will become 1 over 2, 2, and this will become 1. And yeah, we know that sine of 90 is 1. Now we'll go for cosine of 45 into 2. That is, now this time we'll use 1 minus 2 times sine square of, this was 45, 1 minus 2 times 1 over square root of 2 whole square. This will be 1 minus 2 times 1 over, this will become 2, and this get cancelled, and 1 minus 1 is 0. And yeah, we know that cosine of 90 degree is 0. Again, we can go and we can find the tangent also. So tangent of 45 into 2, this will be 2 times tangent of 45 over 1 minus tangent square of 45. So this will become 2 into 1 over 1 minus 1. And yeah, in the denominator we have 0, which is infinity or undefined. And we know that tangent of 90 degree is undefined, or it approaches to infinity. Like at 90 degree we have an asymptote. So in this way we can use the trigonometric or the double angle identities to calculate trigonometric ratios for those angle whose half of the angle, whose trigonometric ratios for half of the angle is known. And we can calculate for using this, we also have triple angle identities, and with that we can calculate cosine and sine for 72, 36 and 18 degree also. So these double angle identities are used in solving equation involving trigonometric functions of twice an angle. Identities can be substituted on such equations to simplify them. Yeah, so basically in calculus also, especially in integrations, uh, sometimes when we encounter some kind of problems, then we usually convert cos square or sine square in terms of sine 2 theta or cos 2 theta, so that we can just go with the integration. So that is all. So Solution given here is correct. Good work. Okay, so this will be question number 8. So I'll just write here question number 8. So it is asking that what is the value of cos minus pi. Okay, cos minus pi. So mm, if I just make an axis here, then the thing is that when we go anti-clockwise, then the angle is taken as positive. So anti-clockwise is positive. This is the basically the sign convention for trigonometric ratios. And when we go clockwise, then the sign is negative. So for clockwise, sign is negative. Now the angles are 0, pi over 2, pi, and this is 3 pi by 2, and this is 2 pi. Going if we go anti-clockwise, but we'll be going clockwise, and now I have to cover the distance of pi here. So this is pi. So this will be known as negative of pi, this angle, and we need to calculate cos of this negative pi. So let's just see. They have used the I think they have used the unit circle. So I'll try to use the unit circle. So in this case, let's say this is 1, and this is 1, and this is -1, and this is again -1. So the coordinates here are 1 comma 0, this is 0 comma 1, this is 1 comma minus 1 comma minus 1 comma 0, and this is 0 comma minus 1. And this, yeah. So for calculating the cosine of any angle using unit circle, cosine of let's say theta, it is nothing but it is nothing but I think it is um, this is x, right? So it will be x coordinate. Cosine of theta, sine will be y coordinate, and yep, sine is y coordinate and cosine is x coordinate. So I'll just write sine theta is nothing but the value of y coordinate, and tangent of theta is nothing but x, sorry, it is y over x. This and this. So calculating cosine of minus pi, it is nothing but cosine of pi only, and cosine of minus pi is nothing but cosine of pi, which is the x coordinate is here -1. So the cosine of negative of pi should be -1. um, let's just check. Okay, with that given, we are given cos negative pi, which is in the second quadrant, so our value should be negative. We also know that on the unit circle, pi and minus pi lies on the same x-axis. Thus cosine minus pi is equal to minus of cosine pi. In the final statement they have made a mistake. Here they have written 1. No, okay. So the thing is that with um, cosine minus pi, this sign will come outside of the cosine. Like there is a property of cosine, sine also. So in the case of cosine, the sine can be taken outside from the just a minute. No, that is not true. That is not true. I just verified that and it is not true. Um, in case of cosine, so the property which here they have given is not valid because in case of cosine, suppose we have cosine of minus theta, then it will become cosine of theta. So basically cosine has the tendency, or like when we used to study in high school, we studied like this, that cosine has the tendency to eat up the minus sign, uh, while other ratios like sine of minus theta was written as sine minus sine theta, and tangent of minus theta was also written as negative of tangent of theta. Um, so cosine of negative pi will be equal to cosine of pi will be equal to negative of 1. So like I don't think that the answer given here, like they have messed up with this property, and the answer given here is not correct. It is not going to be plus 1, it will be minus 1 only. It doesn't matter whether you come from clockwise or anti-clockwise, because cos pi and minus pi lies on the same point, and therefore the value will be minus 1. So I'll just write answer will be minus 1 because the PC property very last statement is not correct. Cosine of negative of a is cos is equal to cosine of a, not minus cosine of a. Um, Cosine has a special, I'll just skip this. This last property of taking minus sign out from the um, angle is um, valid for sine and tan, not for cos. So final answer is minus 1, and the solution given here is incorrect. Yeah, so that was pretty much all for this session. And if you like this session, then please do hit the like button and do subscribe to our channel also. And do hit the bell icon so that you will be always updated with our next live streams. And this was Devansh Prohil, a senior tutor at OneClass. And if you need any homework help, or if you want to submit your own questions, or if you want one-to-one live sessions, then you can check the links in the description below. And I hope to see you soon in my next video. Till then, bye.